Welcome to April 17th LeetCode Challenge, Increasing Order Search Tree. Given the root of a binary search tree, rearrange the tree in order so that the leftmost node in the tree is now the root of the tree, and every node has no child node, and only one right child. So for example, we're given this binary search tree here as such. You want to convert it into a increasing order search tree so that it's basically increasing order. And then you're gonna have the pattern basically one null, two null, and so on, right? So that's basically pretty much how we go about doing that. If the numbers are not sequential, such as you have basically 5, 1, 7 as the binary root search tree called root here, you'll be once you sort it into a increasing order search tree, it'll be 1 null, 5 null, 7 will be the output. So the constraints are the number of the nodes given the tree will be ranging between 1 to 100, and the value of the node itself will be 0 to 1000. So this is ranked easy. So what we're going to do is perform an in-order traversal of the binary search tree. We're going to let the right child of the previous or the smaller node be the current node, then remove the left node to avoid a cycle, then return the smallest node. So in order to do that, we're just going to basically call something called node, and that's going to be the root. We're going to have a stack as well, and that's going to be an empty list. We're going to have a variable called previous or priv, which is going to be none at the moment. And then we're going to have the, let's see, the lowest number, or smallest number, and call it the lowest number, low number is fine, and now it's going to be none. So next thing I'm going to do is, while the stack exists, or the node exists, what we're going to do is, if the node exists, then we're going to stack.append the node to the stack, and then we're going to update node to be the node.left. Okay, else what we want to do is pop from the node, pop from the stack, and we're going to assign that to node. And then within this, we also have the ability to, if it's not the node, then it means that we are able to find if it's the low as well. Actually, I'm going to rename this called lowest, just to make it sound. So if not the lowest number, or lowest node, then what we want to do is update the lowest to be the node, and then we want to exit this if statement, and then we do update node.left to be none, because no left children. Every node has no left children, only a right child. And then if previous exists, then we're going to update previous.right to be the node itself, then update the node, update previous to be the node, I should say, and then the node to be node.right. Exit this, return the lowest, and this would be outside. Run this code. Yeah, seems good. So basically what we're doing here is we define a couple of starter items while we use a while loop basically to do an in-order traversal, and then we basically let the right, we just basically append every node into a stack, and if the node exists, if it doesn't exist, then we pop from the stack, and then what we want to do is let the right child or the previous smaller node be the current node, and then we remove from the left child to avoid a loop, and then we just return the smallest node, which is always connected to the chain. Let's submit this. So run time complexity or time complexity would be big O of n, where n is the size of each node in the tree, I believe. Yeah. Or maybe n log n. Let's see. Yeah, big O of n, where n is the number of nodes in a given tree. Space complexity is big O of h, where h is the additional space complexity, where h is the height of the given tree, so the size of the implicit stack in an in-order traversal. Yeah. Alright, that is all. Have a great day, guys.